So I'm going to be talking about Folsom today. Just out of curiosity, who's used Folsom already? Yeah, Boundary. Oh, Basho. Yeah. Okay. Cool. So I do ops at Boundary and deal with all the deploys and server provisioning and all that stuff, but also try to write some Erlang whenever I get the chance. And if you haven't heard what Boundary is, they are a sponsor, and we do real-time network monitoring. And if you're using Erlang in a distributed fashion, this is totally something you might want to use. So basically we're going to talk about four main things. So what the monitoring systems look like right now, and what our application metrics are, and then how Folsom kind of fits into that, and then lastly, kind of how do you use Folsom. So there are a whole host of legacy monitoring tools, and I'll group those together. Pretty much anything that uses RRD I consider legacy at this point, because it's a terrible, terrible thing. And every single one of those has a different configuration format, has a different protocol, and if you use any one, you end up getting tied into that and if you want to use a different one, you have to write new plugins and do all that sort of thing. So it's always inflexible, and I'll show you some Munin graphs here in a minute. And if you haven't seen Munin or RRD, you'll know you will have seen these graphs before and be disappointed as always. So what I consider like current monitoring tools are things like OpenTSDB and StatsD and Reinman, and hopefully these tools will kind of bring more real-time aspects into it and better analysis of what's actually going on in the systems, and hopefully a lot more new and interesting features and insight into your systems will hopefully come from that. So what are application metrics? And Coda Hale, who most of you probably have heard of before, he in a talk last year said that code generates business value when it runs. And in the end, you don't know your code is running unless you're actually monitoring it, right? So it's an important thing to think about. And then, so application metrics are code instrumentation. So you write code to measure code. You verify the code behaves as you think it should using those metrics. And in the end, you think about how your system works, and then you verify it with code and then tests. And then you also can export results of the instrumentation to your monitoring system you're training, and then also get general stats on the VM. And so what Folsom provides the Erlang developer is application level metrics and lots of different metric types, which I'll go into, and then statistical analysis to actually get information from all those stats. And then hopefully it's easily extendable to, and has a clean API to allow you to do interesting things with it. So before we go any further, I'm gonna start a demo. And I think you'll get a kick out of the demo. So I wrote some code to read my heart rate during the talk. So I'm wearing a heart rate monitor right now, and these stats are getting pulled from so there you go. So there you go. So all these stats are getting, this is a WebSocket in Mistletoe, and it's pulling stuff off this strap from this USB stick, and all this data is going into Folsom. So right now, and so throughout the talk, we'll see. I have Munin running, and we'll see what the graphs look like at the end of the talk. Probably higher than normal. So I'll show some examples of the actual data you can get from it near the end of the talk. All right, so there are a handful of metric types. So there's counters, gauges, histograms, histories, meters, and then just generic VM metrics that we'll all go into. So counters are basically what you expect counters to be, which is just a increment and decrement kind of a thing. And the API for doing something like this is really, really simple. So you can increment and decrement and create a counter by a name. And then there's gauges, which are like point in time values. This is like be a temperature value in a data center or something like that. And so to create it, it's very, very similar. You create the gauge and notify it of the new value. And then histograms are a bit more complex, and it's, I think, probably one of the things that people will probably end up using the most of, which is basically you have a long list, basically, of values that you shove into it, and you end up getting statistical information back from it. So, and then you can also use them sort of like as a timer, as an example here. So basically, you can give it a MFA, and it'll time how long that function takes in execution, and then return that value back into Folsom. And you can do the same thing if you want to wrap your functions in a notify there. So, and histories, which is something that I haven't seen many other folks actually do, which is basically some sort of a error log essentially. But hopefully not your only error log. So hopefully you're shoving this stuff out into syslog or something else. But at the same time, you can stick strings of error messages or whatever into Folsom and be able to get like the last X number of error messages. And so you do something like that. So as you can see, the API is pretty clean, and it's basically the same API for notifying any sort of metric that you have set up. There are a whole host of other ways to actually do this. There's ways to create on notify. So let's say you don't want to have to create all your metrics up front. You can actually supply more information to a different function that will create it anytime that code is hit, which is helpful in certain situations. So, and then there's also meters. And so this is basically kind of your similar to load average, which everyone's familiar with, and same sort of API. So super simple. And then general statistics of the VM, and I'll show an example of this. But here's a bunch of stuff, and I've worked really hard to actually get lots and lots of stats out of the VM. There's lots of stats in there. They're not in the most easily parsable kind of, format. And there's lots and lots and lots of corner cases. So I've tried to do at least a reasonable job of getting lots of the stats up. Some of these you don't want to run on production systems. So be careful with these, because like if you want to list out every single process and you have a million processes, you're going to start hurting things, I think. So yeah. And I'll show some examples of this too. So with the statistics, so this is mostly about the histogram specifically, but basically there's lots of statistics that I actually pull and calculate inside of Folsom, and it's all in one module. So if you're curious what how all that stuff works, I even have R examples commented out in there, so you can see how it compares. And there's even, so if you have two histograms, you can even get the covariance and correlation between two histograms. So you can find out all sorts of interesting things, hopefully. So, and then there's also sampling stuff. So there's 3 different sampling types in Folsom for histograms. So exponentially decaying and uniform, and then just absolutely nothing, just basically just a list. All right, and so then extensibility of it. So as you saw, hopefully, I think that's a pretty clean API. And then there's wrappers. So the idea is you tap into that API to produce some sort of other formatted thing. And the only one I know of at the moment is the one I wrote for Webmachine, which basically gives you a REST endpoint for any of the functions in Folsom. And as a result, I wrote Munin plugins for it. So if you're using Munin, you can tap right into those and pull information and start graphing things. And then hopefully, I hope I know there's some folks that have talked about SNMP and talked about CollectD and some other stuff. So if anyone wants to work on one of those, I'm more than happy to help. So. And then as far as like future work with Folsom is I want to come up with some sort of metrics REST and JSON spec. So that way, if you write a single plugin for Munin, that plugin will work across a handful of different metrics libraries. And I've talked to Coda, and he's on board if we come up with something that's reasonable. So at least that'd be Erlang and Java both would have a similar spec for the REST API. So that would be, I think, a huge advantage. And then also performance improvements. So Folsom has had a whole host of improvements along the way. Anything from actual, math calculation improvements in the statistical library, or even basically being completely bound by Gen-Event and having to actually gut it and talk directly to ETS for all of the metrics storage. So there's a whole host of things that have gone into it, but there's still, I think, some pretty low-hanging fruit that it can still happen. Just a matter of working through it and finding all that. And then also better querying of and slicing of different metrics types, especially histograms, like getting things like I want to see them last 5 minutes of metrics. I don't want the whole sample. That sort of stuff I think is pretty interesting and pretty neat, and something that I definitely want to add into Folsom at some point. And then more metric types. I know the guys at Opscode have a meter reader type that they've built into Folsom as well. So there are a few others that hopefully we can get added in as well. And then there's a whole host of similar tools as well. So there's Coda's JVM metrics. There's Ruby. There's some stuff out of Twitter called Ostrich, and their offshoots as well. So so if we have all of these, hopefully we can come up with a REST spec that will end up making it much simpler to get this data out and use the same plugins for all of these different libraries. So. Okay, so now we're back at demo, and so I'll go through and kind of show you what things look like inside Folsom. So here's my heart rate. Luckily, it's gone down since then. So we're looking a little better now, at least. So yeah, this is just a Mistletoe WebSocket that's pulling stuff off of a C port, and that's talking to the serial port that's this USB interface, and just grabs the data from the air. And so basically, the easiest way to do this is, so here's a list of metrics that Folsom's providing. So this is the Webmachine wrapper for Folsom. And so if you just hit _metrics, then you get a list of metrics that are in here. And so we'll look at histogram first. It's probably the most interesting. So here's a whole bunch of stuff, right? So we have the min, the max, all sorts of different means, because depending on your sample and what it looks like, actually, you may want different types of means. And then median, variance, standard deviation. So skewness and kurtosis are two things I wanted to have in here, so you could actually get the shape of the distribution and that sort of thing. Percentiles, and then also something I recently added is histogram bucketing, but it's actually dynamic now. So it'll actually look at the sample and try to choose a reasonable bucket width and count. So this will actually change over time. So as things update and you refresh, this may or may not update. So, but yeah, so this will actually come up with hopefully reasonable bucket sizes and stuff. That code is a little finicky, but it seems pretty solid at this point. So it's actually something you wouldn't think would be too hard, but it's pretty hard. Something simple that's actually really hard. So, all right. So let's look at a counter real quick. This will not be very exciting, but so there you go. So that's how many times we've had a sample of my heart rate since I started this out in the lobby. So yeah, that's a counter, and then a meter, which might be a little more interesting. So you could think of this as my load average during the talk. So there's my 1 minute, 5 minute, and 15 minute load average, and then we also have acceleration. So we know which direction the load is going in, which is helpful and definitely in certain situations. So as a result, you have all this information, and this doesn't do you a whole lot of good if you don't have a way of actually visualizing it. And one kind of poor way to do it is to use something like Munin. And so here's an example of the histogram. You can see that I started it over here on the right, and if I left this running, it would obviously scroll across. And then you have all the data here, and I didn't have time to actually make it a more pretty graph. But yeah, so that's the main idea. And then, so, it'll be fun. So yeah, here's a meter, and here's a graph of a meter. This is when I was testing the other day, and then that's the today's load average. And in addition to this, there's also Munin plugins for actual Erlang stats. So you can see here we have the different types of Erlang memory being used, and then graphs for those. And then so here's the Erlang Statistics, which is basically different information about run queue and context switches and stuff like that inside the VM. And then also the system variables, which is like basically logical processors and just like kind of more static stuff, but it can totally be helpful. So, and then as far as some of the other stuff, let's take a look. So since I got my REPL here, I'll show you some examples of some of the other things. So. This might be a really crappy thing for a low resolution thing, but oops, did I spell it wrong? Or? Yeah, metrics. So here's an example of like information about every single process that's currently running in the VM. And if you, like I said, if you have like 1 million messages or 1 million processes, this is probably not something you want to run. But you can get all sorts of interesting information out of the VM. And so yeah, so this is like some of the interesting things you actually might want to know is like how many messages are in the queue for a specific process. This is helpful. And lots of other things. So let's see, it's another one.
How is it different from the processing?
So basically this basically takes that information and sticks it into a prop list, so you can actually key on the process ID, and so it's basically easier for, if you had a library that wanted to collect this information, it'd be easier to deal with than because like in each of the different VM stats, I've tried to make it far easier to parse this stuff, because you can look at the code in Folsom. It's pretty gnarly to actually get this stuff out and get it into a reasonable format, because it's kind of crazy. I can show you the code if you're curious. I'm more than happy to. And so let's see, like port info. So there you go. So you can see what's interesting about this one actually is like the actual TCP socket information will be in here as well. So you can see stuff like this, which is awesome, right? Like I want to know how many packets I've received and sent on a port, that's pretty excellent. So this is all in the VM. It's just kind of hard to get to. So, and I think that hopefully Folsom's made it a bit easier to get this sort of stuff, and hopefully bring some light to some parts of the VM that people haven't seen yet. So you can get some pretty interesting things. So let's see. So yeah, I'll show some code. Sure. So let's see. This will be easy. So just as an example, so here's my VM. So let's see. So just to deal with the the code for the statistics function call, this is the kind of stuff that you have to do. Just to get things into a reasonable format that is actually JSONable in the end. So here's the one here's a big block for system info to kind of convert things, and so it's convert stuff for CPU topology, for get port info. There's lots of stuff that wraps up the different primitive INET stuff to get actual info from the sockets and that sort of thing. In here. So yeah, so if you're curious about what all sorts of information that the VM actually produces, you can go in here and kind of check it all out. Also, what I find which is nice, I think, about Folsom is that the two modules, there's only two modules that contain all the statistics functions. So if you want to write a statistic function, don't write it, come in here, and if there's a problem with it, fix it, and then just steal my modules and contribute back code changes, because it's much better to have maybe a canonical example of how to do all this stuff. So yes, there's all sorts of statistical functions in here. So if you ever need a statistical function in your actual app code, then maybe you can use this.
Break that out into a separate library?
Possibly, yeah. I mean, it's a reasonable thing to do, probably. So I actually stole some of this from SCUtil, which is a library that I think kind of like Jungle, where it just dumped a bunch of modules into the same thing and tarred it up and called it a library. And so yeah, so some of that stuff is stolen from there, and then fixes have been contributed and that sort of thing. So yeah, maybe I'll do an Erlang Statistics library or something like that, and just break this out into its own thing, because I think that might make a lot of sense. So there's a bunch of stuff in here. So, but to actually add, I'll actually show the code to add stuff to your app. So let's see here. Let's see. Am I on the right branch? Yeah. Okay. All right. So just to show you how to add a metric is so here's my init function, and I have it creating 3 different metrics. So those are the 3 we saw earlier in the JSON, and so I'm creating these, and then once they're created, in my handle call, I'll have it notify each of these of new information. So with the hist, I am sending it the actual heart rate monitor data. So that's the actual heart rate, and then which is right here. And then for the meter, I'm doing the same thing. And then for the counter of how many times we've actually had a sample or something like that, I'm just incrementing this counter right here. So yeah, it's pretty easy. All right. So yeah, that's pretty much Folsom in its entirety, almost. So yeah, you guys have any questions?
So can you talk a little bit about how do you use the system stats and boundary? Do you plot?
No, so yeah, we don't plot those. It's mostly something you want to use almost in debugging sometimes, just so you can find out what things are going on in the system. We plot so the ones that we plot are the system, the statistics, and the memory. And those are 3 function calls actually in the Erlang VM that you can call to get the same sort of information. Just Folsom makes it easier to consume. So, but the other ones, so like the ports and the process info, those usually you don't want to run on a frequent basis because you're just going to get a shit ton of stuff and it's not going to be a whole lot of help. So, but in debugging is totally helpful. So, yeah.
What's the overhead of Folsom when running a system?
It's pretty light since I took out Gen Event. So for a while there, Gen Event became a real bottleneck, and so you'd end up in this normal Erlang situation where you have a huge queue waiting on a single process. And so getting rid of Gen Event and talking directly to ETS, it's been pretty low since then.
Is it possible to run handle 5K, 10K events per second?
Possibly. Talk to the dudes at Opscode because I know they did a bunch of testing. And so the guy that's giving the talk, I think maybe today or tomorrow, about switching from Ruby and CouchDB to Erlang and MySQL, Seth, he did a bunch of load testing on Folsom. And so he'd be able to better tell you.
What about memory consumption? Do you accumulate the entire history of all events? Or just
No, so whenever you set up so the default sample size for like a histogram is like 5,000 events. So there's caps to everything. And I think there's pretty sensible defaults. So as long as you're bounded by memory on the machine and bounded by the number of events that you set whenever you create a new counter or a new histogram or something like that. Counters and stuff obviously won't take up much space, but histograms and histories might. So.
Wait, last question
Mm-hmm.
is, if you do process info, is it possible to just get certain fields if you have overloaded process?
Not at the moment. It's just right now. It's just like everything because it's got to call a few different function calls to get all that information and combine it all together. And so I know at least one of them, even in the Erlang documentation, says don't run this. So yeah, but in debugging situations, it's totally helpful. But maybe a reasonable idea would be to be able to give it a process ID and be able to get the same information for that specific process. But yeah, we can see. It's just a matter of getting small matter of code. So yeah. So yeah, as you see, the graphs are updating, so that's cool. So let's see. So they're getting a little wider now, so you can start to see some of the lines actually in the graphs. So there you go. So yeah. Any other questions?
Are window sizes for meters configurable?
Most window size, yeah, all samples. So like meters and histograms are all adjustable on creation. So they're not updatable later, but on creation they should. I know histograms for 100%. I think meters too.
Do you track timestamps for observations?
Timestamps for what?
For observations, so that you can...
Not at the moment. So except for histories. So histories are sorted on epoch time, and so if you stuff something into a history at a single point in time, you'll be able to get that back out, and it'll be sorted on the timestamp.
What kind of heart rate monitor is that?
It's a Garmin. So this is the Garmin thing, and then this is the Garmin USB stick. And so yeah, they use this protocol called ANT+, which is like a standard protocol for dealing with low power athletic data. That's pretty much the only place it's used. So yeah, so this uses a C port to talk to the thing, and the C code is terrible. I found it on some forum because I didn't want to write it myself, and so yeah, but it does work. I had to change it so the C code so that Erlang would actually understand it. But I started writing a serial reader-writer library for Erlang because there's not a good one. So I'll probably convert it to that because the C code is actually GPL, so that's not really all that conducive to actually doing something with it. So yeah. So that's all I got. So thanks, guys.
Thanks very much.